We can also deal with absolute value inequalities, and just as a beginning sort of warning, keep an eye out for inequalities that can be solved without any formal steps, without any actual real algebra work other than the basic understanding of what an absolute value is supposed to do. Absolute value turns stuff positive. Absolute value greater than or equal to 0. Hey, you know what? That's always true. That always happens. I don't need to do any work. I can straight up go, my solution is all real numbers. Absolute value less than 0, that never happens. I don't need to do any work for that. That never happens. No solution. Now, of course, that's not going to happen very often in your exercises. Most of what you're going to have to practice is actually solving these absolute value inequalities where you have to do work. So what we're going to use is something that we could extend to any other kind of inequality situation. So no matter what kind of inequality we might have, we can adapt this method that we call the test point method to any other kind of inequality that might show up. First step, replace the inequality with an equal sign. Well, as long as we're equipped to handle the equation business, then we should be equipped to handle the inequality business. So let's bring up at the bottom of the screen here an example and slap down that first step. We will replace that inequality with an equal sign. If we have this example 10 greater than or equal to 6 plus the absolute value of the quantity 3t minus 4. We're going to replace the inequality sign with an equal sign. 10 equals. No more greater than or equals, just 10 equals. And then we want to solve that. So we have our previously mentioned process of solving that, where we would get the absolute value by itself. We would take what is inside the absolute value, set it equal to a positive, and set it equal to a negative. And in this particular case, that gives us t equals 8 over 3 and t equals 0. Now we've got these two numbers. Those are going to be taken and put onto a number line. Now two values on a number line, going to end up breaking that number line into 3 chunks. To the left of 0, in between 0 and 8 over 3, and to the right of 8 over 3. So we're going to have those different segments of our number line. Which segments do we want to report because they're part of our solution? This is where the test part of test point method comes into play. From each of those segments, we're going to pick a number and test it in the original inequality. So let's take a look at what that is looking like in this example. Putting those numbers onto a number line and then saying, okay, if we got to worry about to the left of 0, we might pick a -1 to test. In between 0 and 8 over 3, well, a nice convenient number to pick to test would be a +1. And off to the right of 8 over 3, well, that's pretty close to 3. So to the right of 8 over 3 is actually 3. We should go ahead and test that sucker. And we're going to, based on that test, get either a true statement or a false statement. So let's again see how things play out. That original inequality says 10 is greater than 6 plus the absolute value of 3t minus 4. So we put in the -1. 3 times -1 is -3, minus 4 is -7. The absolute value of -7 is +7. Plus 6 is 13. 10 greater than or equal to 13. That's false. Try the t equals 1. Test that out. That's going to work out to be true. Try out the t equals 3. That's going to work out to be false. So, however that third step works out, what we are interested in is only going to be what's marked true. The only other issue that we have, what about the 0? What about the 8 over 3? Well, we've mentioned that idea before with just our regular old inequalities. Our inequality symbol is going to have control over, do we include or omit the 0? Do we include or omit the 8 over 3? And in this particular case, because that inequality originally said greater than or equal to, the 0 and the 8 over 3 are going to be included in our solution, which is only going to be this middle segment. So bracket 0, comma, 8 over 3 bracket, using those brackets because that inequality symbol originally had the or equal to. 10 is greater than or equal to, so those are included. Now let's do one of these together straight up from scratch. So let's say that we are dealing with, at first here, the absolute value of 1/2 c plus 4, pause, plus 1, greater than 6. According to our test point method, we're going to start by replacing the inequality symbol with an equal sign. So blah, 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 blah equals 6 is how we're starting that out. And part of that first step is to solve that equation. So we can solve that starting with get the absolute value by itself. So get rid of the plus 1 by subtracting 1 on both sides. Now that the absolute value is by itself, we want to break this up into the two different equations. The first one, the absolute value is equal to the positive 5. And we have an equation that we can solve there. So if that is the case, we would subtract the 4 on both sides, multiply by 2 on both sides. So c is equal to 2. We have the other version of the equation where the stuff in the absolute value bars needs to be equal to a negative 5 in this case. Because we already know what steps we're supposed to do, we know we're supposed to subtract 4 and we're supposed to multiply by 2. We've already got a roadmap for what to do on that other equation. We just need to do that based on that starting place. So subtract 4, multiply by 2. Here are the two numbers that we want to now put onto our number line. C equals 2, C equals negative 18. Remember with your number lines, left to right, negative to positive, smaller to larger. So out of those two, the negative 18 is going to be to the left. The C equals 2 is going to be to the right. And once again, that is break things up into 3 sections, 3 segments. To the left of the negative 18, in between the negative 18 and the positive 2, to the right of the positive 2. So we're going to pick a number from each of those segments, and we're going to test those out. We can pick stuff that's convenient because this has a 1/2. Let's pick even numbers. So a negative 20 from the left-hand segment. It's always nice if we can pick 0, so 0 from the middle segment, 4 from the right-hand segment. Test each of those out, so we would put those into our inequality and see how things play out. Now, rather than just saying, here's the stuff, true, false, true, let me just talk it out, right? Negative 20 times 1/2 is negative 10. Plus 4 is negative 6. The absolute value of negative 6 is positive 6. Plus 1 is 7. 7 greater than 6. True or false? 7 is greater than 6. That's true. Test out the 0. 1/2 times 0 is 0. 0 plus 4 is 4. The absolute value of 4 is 4. 4 plus 1 is 5. 5 greater than 6. True or false? Sucker's false. Plug in the 4. 4 times 1/2 is 2. 2 plus 4 is 6. The absolute value of 6 is 6. 6 plus 1 is 7. 7 is greater than 6, just like it was before. So that is also still true. Going on there. We want to pick the stuff that is going to be marked true. We would want to also know, do we omit or include the negative 18? Do we omit or include the 2? Our original inequality symbol is what's going to control how that works for the negative 18 and the positive 2. Because the original inequality symbol was just a regular greater than, the negative 18 omitted. The positive 2 omitted. So our solution for the left-hand section, parentheses, negative infinity, comma, negative 18, parentheses. There's more true stuff, so we got to union that. Parentheses 2, comma, infinity, parentheses, boom, there we go. Test point method, great. But some people are more visually oriented and might be instead thinking of the graphing skills that we're already developing. So let me just make a final comment here about that. We could use our graphing calculator and our graphing skills to be able to try to piece things together. So in this particular case, we might say the left-hand side of that inequality we will set up as one of the entries in our graphing calculator. So the y1 is that absolute value, 1/2 x plus 4, pause, plus 1. And then y2 is going to be the right-hand side of that inequality, so y2 is just equal to 6. Because the inequality symbol, we would be interested in our picture, where is the y1 graph above, greater than, above the y2 graph. So if we can identify where those two graphs intersect with one another, then we know and can tell where is our y1 graph above the y2 graph, and where they are equal to one another. Well, we know now from doing this with the test point method, that's going to be the negative 18 and the positive 2. Notice that we just switched out the c for an x in order to do the graphing stuff. No big whoop, but there is that option that's available to us as well. As is sometimes the case with graphing stuff, if it's not nice, like that earlier example that had the 8/3, that would not be nice for us to try to identify by eye, whereas the negative 18, that's identifiable. The positive 2, that's identifiable. That graphing stuff might be limited because of whatever numbers that we might have showing up where our two graphs intersect with one another. So we do have to keep in mind that there might be those limitations. If you can use it and you want to use it, go right ahead. If you can't use the graph, if it's just not working out for you, you got to revert back to that test point method. And of course, if the instructions specifically tell you, do this with algebra, do the test point method, or do this graphically, do it graphically. And if they don't say anything about it, again, take your pick.